Hello. I'm going to go through the lesson of how we connect a function to its derivative to its second derivative and help you make connections between the three things. So maybe this is something I wish I had in your notes last year. I made a whole pretty thing, so maybe you can print it so that you can take notes on top of it. I'm going to try to go slowly enough and kind of color code things a little bit, so we'll see how it goes. So our first step is going to seem pretty easy. When we have f of x, we can say that f of x is increasing, which means from left to right we're moving up. We can say that f of x is, okay, go. Oh my God, yes, go. God, that's him asking for a cookie. You can say that f of x is decreasing, which would mean from left to right we're going down. F of x can have a max, f of x can have a min. Obviously I know f of x can have neither of those things. But I wanted to write down what is true about the derivative of f when f is doing those things. So first of all, be really careful that you don't use the word it. Even though it's a mouthful to keep saying the derivative of f, and it's annoying to write, although writing f prime of x is really no more work than writing it. We can't say it when we describe any of these things. So what I mean by that is if I say, why is f of x increasing? I would have to say because f prime of x is positive. And I can also just put a plus sign that would indicate that I understand positive. When f of x is decreasing, the first derivative is negative. And when f of x has a max, that means the first derivative changes from positive to negative. Oops. So the first derivative goes from positive to negative, which means the function will go from increasing to decreasing, and therefore we have a max. What happens when we have a min? That means the function changes, or the derivative changes from negative to positive. So I put that there because when open-ended questions come up, it's really important that we say them the right way. And we're also going to be looking at graphs of the derivative and deciding what is true about f. So for example, when I know that a derivative is positive, I then know that the function itself will be increasing. Well, what also does positive mean? Positive also means above the x-axis. And this was I know people had trouble thinking about this last year. What does negative mean? Negative also means below the x-axis, and so forth. So when I'm going to be looking at a graph of f prime, these things are going to tell me what's true about f just by knowing what's true about f prime. So we're going to fill out all of these and then we'll go through an example. So if f of x has a horizontal tangent line, I'll use pink again. So if f of x has a horizontal tangent line, that can look three different ways. Either it's a min, or it's a max, or I have a potential point of inflection, a flat part of my graph. Well, what's true about the derivative? What's true about the derivative is the derivative will equal 0. Whereas if f of x has a vertical tangent line, so that can look something like this. I can't draw it. Oh my gosh. Here we go. Okay, here we go. Like that. Okay, vertical tangent line there. Or even where we have a cusp, we can have a vertical tangent line here. Well, what's happening there is my derivative is undefined. So if I had a fraction, the top of the fraction would be 0 in this case, and the bottom of the fraction would be 0 in this case. Okay, so now let's go to concavity. I'll stick with the same pink here. Okay, so if a graph is concave up, it looks like a cup, and that can either mean the function can either be decreasing or increasing and still be concave up. If something's concave down, it looks like a frown. That means the function can either be increasing and concave down or decreasing and concave down. And a point of inflection happens when the concavity changes. So when we go from concave up to concave down or vice versa. And also that can be increasing, decreasing, whatever. So what's true? Let's skip down to the second derivative because we understand that a little bit better. When the function is concave up, the second derivative is positive. When a function is concave down, the second derivative is negative. And when our function has a point of inflection, the second derivative changes sign. It doesn't matter if our second derivative changes from positive to negative or negative to positive. A point of inflection doesn't classify like which way it's going. So we just know that the second derivative changes sign. I know we talked about this last year and it seemed confusing, but I think about these things in terms of like a ladder. So if you look up to here, when my derivative is positive, there is a fact that's true about the step before. And that is that if a derivative is positive, the original function is increasing. If a derivative is negative, the original function is decreasing. Well, I can kind of take that idea here and say, if the second derivative is positive, when I pop up a level, it means that this first derivative is increasing. So if I have a function that's concave up, not only do I know that the second derivative is positive, I also know that the first derivative would be increasing. Likewise, if my second derivative is negative, what does that mean about the level that comes one up? Well, look over here. When my first derivative was negative, the function was decreasing. So when my second derivative is negative, the step before, or the first derivative, is decreasing. So if my second derivative changes sign, that means my first derivative must be changing from increasing to decreasing, or vice versa. So that means my first derivative has a max or a min. And this will be helpful when we look at pictures of graphs to see if we are given a derivative, what that means about the original function. So if we're given a derivative and the derivative is increasing, the original function is concave up. If the derivative is decreasing, the original function is concave down. If the derivative has a max or a min, the original function has a point of inflection. Okay, and then because I was talking about concavity, I put something in about tangent lines. So if a function's concave up, tangent lines are located below the curve of f of x. If a function's concave down, tangent lines are going to be above the curve. Because we've been asked this a few times. So if we use a tangent line to make an approximation, so if we have that kind of question where we have a concave up curve and we have a tangent line, our tangent line approximation is going to be an underestimate. And if our function is concave down, then the tangent line is above the curve and the tangent line approximation will be an overestimate. Okay, nothing to fill in here or here. Whew. Okay, so put that aside, and I was going to go through visually what some of this might look like. I have a note. Okay, so just if we wanted like a quick visual summary of what this looks like. Okay, if my function is increasing, the derivative will be positive. If a function is decreasing, a derivative will be negative. If a function is concave up, the derivative will be increasing. The second derivative will be positive. If a function is concave down, the first derivative will be decreasing. The second derivative will be negative. So let me write up, if the function is increasing, this is positive. If the function is decreasing, the derivative is negative. If the function is concave up, then the derivative is increasing and second derivative is positive. If the function is concave down, the first derivative is decreasing and the second derivative is negative. Okay, take a minute. Fill this out. Okay, press pause and fill this out so that you can start to have some of these reactions quickly. So push pause and come back and see if you are right. I'm going to keep going so that I can do it all in one video. So f of x is increasing when? So if you need to go back and look, well, when is f of x increasing? It's increasing when the derivative is positive. When f prime is positive. F of x is decreasing when f prime is negative. So use this to test yourself. F has critical values. We didn't actually say that on the thing, but critical values when the derivative is 0 or when the first derivative is undefined. F has a max when f prime changes from positive to negative. F has a min when f prime changes from negative to positive. F is concave up when f prime is increasing. And f, oh shoot, this is supposed to be double prime. Is positive. F is concave down when f prime is decreasing. And f double prime is negative. F has points of inflection when f prime has a max or min. And when f double prime changes sign. Okay, you need to memorize this. You need to have it going quickly. I mean, memorize, or, I'd prefer you understand it so that you don't have to refer back to the notes all the time. But you need to understand it and be able to move quickly through it. Yep, that's it. Enjoy.